This last section, this set of formulas gives me the exact values of a few more angles that aren't on my unit circle. And for this one, we're looking at half angles. So we did sum and difference where you could add or subtract two angles and use the formula. The last one we did was the double angle. So if we doubled the angle, what would the exact value be? For this one, we have these angles that aren't on our unit circle. And what we can do is find what happens if we double the angle, and we'll use a half angle formula. So it's a little weird, I guess, going back and forth to start off, but these formulas all kind of work the same like the ones we've been doing. Some people even say these are easier than some of the other ones we've been doing. We'll see for ourselves. So not a lot of problems, I think, for us to get the gist of it. It shouldn't take us too long to go through this section, and hopefully we'll have some time to work on stuff. But so there's a few little concepts that we got to understand. So if I look at this angle that I'm given, we want to find sine of 157.5. Is that on my unit circle?
No.
It is not. So I can't just give the exact value. So I need a formula to be able to find that. So what you do is when you have these angles, you're going to multiply the given angle by 2. And then you'll be able to use the formula. So this angle is theta. To use the formula, we're going to have some number divided by 2 that comes out to equal r theta. So the way we find that is we multiply this by 2. But before we go too far, what quadrant is this angle in?
Would be second.
It would be second. It's less than 180, but it's bigger than 90. So this would fall in the second quadrant. So I'm going to just write this here because that's going to be important in a second. Let's say quadrant 2 is where angle is. I should have said angle is in quadrant 2, but I wrote quadrant 2 first, so is where angle is. All right, so I will come back to that in a second. So to figure out which angle I'm actually going to use to get these exact values, I just multiply this angle by 2. So I got 157.5 times 2. And I get 330, I think.
Yep.
315? Yeah, you're right, 315. So 157.5 times 2. And like Drew said, I get 315. So do we know where 315 is on the unit circle?
Yes, we do.
Yeah, so we can use those exact values. This is the angle that I'm going to use for my formula. So I multiplied these two together and I got 315. So what we're going to do is the half angle for 315 divided by 2, which is the actual angle that we want to find the exact value of. So if I went backwards and I divided 315 by 2, I'm going to get this angle that I actually want to find. All right, so these formulas aren't too complicated, but what we'll do is use this angle as we put it into the formulas. We'll use 315. All right, so you do have a decision to make. Will this half angle be negative or positive? Now it's easy. We said this angle is in which quadrant? The first angle that we're looking at, 157.5. Second quadrant. So will sine be positive or negative in the second quadrant?
Negative.
Sine?
Oh, positive.
Positive. So you have to decide, am I going to want a negative outcome or a positive outcome? Since this half angle is in the second quadrant, sine's going to be positive. So I'll choose the positive option. And normally you just leave this blank, but I'll put a plus there just so we know we had to choose plus. And we chose plus because this angle's in the second quadrant and sine is positive in the second quadrant. So we're going to go with the positive option. Does that make sense?
Yeah.
Not of 315, but of our original angle. Now we can use the formula. So we got, see how much space I'm going to need. Not that much space. So we got 1 minus cosine, and I'll write it out, cosine of 315 divided by 2. And I write my radical at the end because if I don't, it'll look bad. I write it this last thing. All right, and I won't write the positive anymore. I'll just won't put a negative sign, which will make it positive. What's cosine of 315? Is 315 a 30, 45, or a 60? 45. It's the middle angle in the fourth quadrant. So the x-coordinate is root 2 over 2, and it's positive in the fourth quadrant. So I'm going to change this to be positive 2 over 2. So I got 1 minus cosine of 315 is 2 over 2. Yeah, I should do square root 2 over 2. And I do that last because if I don't, it won't look good. So I'll write everything inside of it, and then I'll come at the end and put it in there so it all fits. All right, everybody okay? So I want to get this whole number and this fraction together. I need a common denominator, right? Of what? Root 2 or just 2? Just 2. So I'm going to convert 1 to be 2 over 2. So 2 over 2 minus root 2 over 2, all divided by 2, underneath my radical. So we changed 1 to be 2 over 2. So now I can put these two numbers together. I would leave it as root 2 minus, 2 minus root 2 all over 2. Not cancel. They do something though. All right, we okay? All I did was just write it as one. All I did was write it as one thing.
Oh, okay, never mind.
So, all right. Okay, so at this point, I would keep this top fraction, change the multiplication, and flip from 2 to be 1 over 2. I could do that for sure, or since the bottom is a whole number, I'll just move it up here and do 2 times 2. It's the same as multiplying this top by 1 over 2. So, keeping this, and then in the denominator, I'll do 2 times 2, which is 4. I did the same thing as if I keep, change, flip. If I kept the top, because we know what the square root of 4 is. Yeah. So when it's like this, I could rewrite it giving the top its own radical and the bottom its own radical. I can reduce this 4 because the square root of 4 is 2. So I can rewrite that as the top can't change. It's 2 minus root 2, and it's still under the radical. But I can divide this just by 2 because the square root of 4 is 2. All right, just to be clear, I could have split these up. And I could have said like that. And then this is the square root of 2. So I'll just put, sorry, this is just 2 over what I had on top. All right, everybody okay with how we got here? And that's it. It looks a little bit crazy, but I don't have any radicals in the denominator. This is in value. This is actually the exact value. And it looks a little crazy with the double radicals, but this is my exact value. We have any questions?
So is there nothing you do with the double radical there? You just leave it as root. So the square root of 2 minus root 2. How
Yep.
can it be a square root in the square root?
I mean, it just is. I mean, we didn't have a problem with it up here. You know, we didn't have a problem with it here.
Yeah.
It's just because of how it looks. Now we got a problem,
Yeah,
but
now it looks weird. So there's nothing, that's just how it is.
that's just how it is. So if I was like putting these together and I wanted to round it, I would do the square root of 2 first. That'll be like 1 point something. 2 minus that 1 point something. I do square root of that, and I get, I think, 1 point something. I divide it by 2, and that's my answer.
Okay.
So, yep. You guys are young mathematicians.
It just looks, it looks fine.
Yeah, it looks weird. You probably haven't seen nothing like this before in your life.
How do we get to that number if we're divided by 4? Oh, okay.
How do we get from here to here?
So I take square root of top and bottom. Yeah, I got it.
Okay. All right.
Same thing.
All right. Any other questions? Okay. Let's go to number 2, and let's do one that has a radical. All right. So my thinking would be, is 5 pi over 12 on my unit circle?
No.
It's not, but I gotta find an exact value. Only way I can do that is if I use some kind of formula. Right? So what we're gonna do is,
Isn't it where you went like?
like we say, when you're given an angle that's not on the unit circle and you're doing the half angle formula, you multiply the given angle by 2. Then that lets you use the formula. So we want an angle that's twice as big as this angle. So I'll do 5 pi over 12 times 2. What does that give me on the top? 10 pi over 12. Can I reduce that? I think they both have a common multiple of 2. So 10 divided by 2 is, do we know where that's at? 5 pi over 6? It's on there somewhere. So I can find this exact value. It's the 30.
32nd one.
Yep, in second quadrant. Good job. Because it's 1 less than the bottom. Then the top is 1 less than the bottom. Okay, so this is the angle we'll plug into the formula we're about to use. Now, before we get too far, we do need to figure out where 5 pi over 12 is, so we can go ahead and select the sign that we need. Because when we do this for cosine, we have to decide, will it be positive or will it be negative? So what I do is I need to figure out where 5 pi over 12 is.
It's the second one.
Second quadrant.
Yeah.
Pi over 2 is here, pi is here, 0 is here. And we want this angle, our original angle. 5 pi over 12. Where is that at? First, second quadrant?
Second,
Second? Why you say second?
because I'm looking at the chart.
We're looking for 5 pi over 12.
Oh, just kidding.
Our original
Number
angle.
6. I just told you. That's not on.
I'll make a little note. We say 5 pi over 12 is in,
The first.
yep, is in quadrant 1. Or you write first quadrant or top left, whatever. Makes sense, it's your notes. So cosine is plus or positive.
Plus.
You can put plus if you want. So cos is positive. So we'll choose the positive option. All right, so let's do this. What we're doing is cosine of 5 pi over 6 divided by 2.
Chinese. Are you going to prom?
I think so. The formula for cosine. We'll choose the positive option. I'll write a plus just to remind myself that, hey, you were smart and you chose the positive option.
No.
All right, so I just write it. If it was negative, you would leave the negative out there. For positive, you don't really have to write anything because it's understood to be positive. So to use this formula, I say cosine theta, and I'll write out what we're about to do. We're going to do cosine of 5 pi over 6 plus 1 divided by 2. 5 pi over 6. Since it's over 6, what type of angle is it? 30, 45, or not 60?
45, 60, 30. 30, final answer.
Are you sure?
Yes.
Because you said every angle. It's a 30 because it's over 6. I know the 30s is the lowest angle close to the x-axis. And I know it goes 3, 2, 1 for the x's. What's cosine of a 30? It starts off 3, 2, 1, 1, 2, 3. 3, 2, 1.
3 over 1.
3 over
2.
2. It's the x coordinate. So cosine of 5 pi over 6 is root 3 over 2. Should this be negative or positive 3 over 2?
Okay.
Which quadrant is this angle in? This angle right here that I'm pointing at?
First.
That I'm pointing at.
Second.
Second. Is cosine negative or positive in the second quadrant?
Positive.
Negative.
Negative. So this should be negative 3 over 2. Now I like your enthusiasm. You make me second guess myself when you say,
Good.
because I feel like maybe she's right. She's real confident. All right, so at 150, cosine's negative 3 over 2. Everybody okay with this? Then I'll add 1. Then I'll divide by 2. This is my answer. I just got to simplify it. Yeah, James? Yes.
Wait, I also have to.
Ooh, that's a dilemma, isn't it?
Him saying I have to-
Whoever touches the door first can go first.
Need to use the restroom.
You can go next. All right. I probably want to get the top numbers to be just one fraction. What would I rewrite 1 as?
3 over 2. 2 over 2.
2 over 2.
Yeah, Jay. I got it the second try. Bruh. You put it over 2.
Yep, all over 2. And then I'll add these two together since they have the same denominator. And I can't put the top numbers together, but I'll just write them in the same line. So negative root 3 plus 2 all over 2
All over 2.
all over 2.
And guess what, guys? I got this. And it's
You do got this.
negative 3 plus 2 over 4.
Over 4. Good job.
Square rooted, but then it changes to 2. Oh.
You got it? Awesome. All right, so I keep change flip, but since this is a whole number in the bottom, I'll just multiply it by this denominator. 2 times 2 is 4. So I get negative root 3 plus 2 divided by 4. All under the radical. Stop me if we need to. What was the square root of 4?
2.
2. So I can take this 4 out.
You can go potty now. Can I? Him because he went potty. But she didn't say. Booyah.
To be fair, he just asked me to go to the bathroom.
And
No idea what he did. For whatever reason, a lot of people have fun in the bathroom during.
why wouldn't you?
I walk by the bathroom, I hear a lot of laughing, and I don't know what goes on in there. Probably don't want to know. So I don't know what happened. But you can go if you want to. All right, we okay? Questions how we got here? Okay. Don't know what questions to ask just yet, maybe? All right. Ready to do this last one?
Nope.
Not yet?
No, July.
Well, it's ready for you.
I'm more ready than I can be, coach.
You are? Okay, I like that's a great answer. Great answer.
It's gonna be in the third quadrant.
Is it? Because it's the biggest on the paper?
That makes sense.
Yeah.
What?
Huh? Look.
Hmm?
Do you see?
Oh,
the
okay.
biggest?
Yeah. Because I zoomed in on the third quadrant.
Yes.
Gotcha.
No, I didn't even see that, I'm gonna be honest. I just saw it said
I
between
think
pi
you're fitted.
and 3 pi over 2.
I think
Yep.
Okay, don't share it like that, James.
All right, so just to be clear, we're going to do all three. This time, I'm not giving a half angle, but I'm actually giving a ratio of theta. And I'll say this again. I'm not giving the ratio for theta divided by 2, which would be my answer. I'm only giving what theta is. I don't know what the angle is, but I have the ratio, which is okay. So this is actually 3 problems in one. It's like 3 birds, 1 stone. We're going to do 3 problems in 1 problem with the same values. So just to be clear, if you were given this, your only goal might be to answer what is cosine of theta divided by 2. And you just do that one. We're doing all 3, so don't feel like this is one problem you always have to do as a whole big thing. We're just doing this as 3 problems in one, all right? So let's look at what we're given and try to make sense of it. It tells me that sine of theta is -4/5, and it tells me that this angle is greater than pi, which is right here, but it's less than 3 pi over 2, which is right here. So we can conclude that this angle is in which quadrant? The third quadrant.
You already talked about it.
We did.
You weren't.
Okay? Everybody okay with why I drew this angle here? It falls within this interval. It's larger than pi, but it's less than 3/2.
Because it's the biggest on the paper.
So, yeah, over 2 is like the 1/3 long, right?
Yeah. 3/2 is 270. It's between 180 and 270. It's got to be somewhere here. Everybody okay with that? All right, so let's see where we should go. Let's figure out where the half angle is. So this is just theta. We want half of this angle. So if I knew this number, I would just divide this number by 2. I don't know this number, so I can't. There's no angle to divide by 2. The way I figure out whenever you're given an interval, divide each end of the interval by 2 because you want half of it. So divide it by 2. I'll even make a little note for myself. Let's say to find
Hold on. I gotta write this down, see if it makes sense.
theta over 2 divide interval,
What does that mean?
the interval. So the interval is like what you're between. So like say you're driving on the parkway and the interval you can drive, on I-65, what's the minimum speed you can go?
70.
Minimum.
0.
45.
You can't go 0 because you're going to make everybody crash.
Oh, you said minimum.
40. It'll have a minimum speed. Don't go slower than 40 because you're going to make people have a wreck.
Why would
But you can't go faster than 70,
Says who?
the speed limit.
You can't go faster than 80?
You shouldn't go.
Fine, in your mind.
I'm looking at the signs. We're not following your driving rules. You're going to have me in driving school.
No. You can go
So-
20 already.
It would say minimum speed 40, speed limit 70. So you have an interval. Can you go 45?
Yes.
Yeah.
Sure. People going to honk at you and say, get out the way.
But like,
But you can go 45. So it's the same thing here. This is your lower interval.
Oh, so
This is your upper.
Dinosaur, or the
That's-
alligator thing.
Yeah. So that's the interval. So you divide the interval by 2. And then I'll write what we did. We did theta over 2. All right, so this is me dividing the interval by 2. These are the numbers that we got. And then we'll say the half angle is in quadrant 2. All right, so you divide each end of the interval by 2. That'll tell you where the half angle is. Hopefully this makes some sense. So when you go look back at it, you'll kind of recall what we did. All right, we ready to find these values? All right. So let's do it. Let's do cosine half angle first. And if we look at all these formulas, we only need the exact values of what? Cosine and sine? We were given sine. Let's go ahead and write what cosine would be. So if we make our triangle by going to the x-axis, I know sine's ratio is what two sides? So,
O and H.
O and H. So I label my triangle accordingly. The opposite side is 4. The hypotenuse is 5. Should either one of those numbers be negative? The 4, the left one. Good job. The radius is always positive. The hypotenuse is always positive. I think this is a special triangle that we know the values of. 3. Yep. So just like that, I get 3. Should 3 be negative or positive?
Negative.
Negative, because I go left 3, then I go down 4. We didn't even have to do Pythagorean's theorem. Now, if you didn't recognize it as a 3, 4, 5 triangle, you do Pythagorean's theorem. And you don't have to write this if you know where that 3 came from. Don't write it. I get 16 plus b squared equals 25. B equals square root of 9, which equals 3. That's how we got 3, Pythagorean's theorem. So, hypotenuse, opposite, adjacent. What's cosine's ratio?
A and H.
Okay, what's A?
-3.
Over
5.
5. All right, now we're ready to use the formulas. Well, we spent like 5 minutes just talking about this. All right, so let's do it. Cosine double, what are we doing first? Yeah, cosine double angle. All right, let's choose our sine. The half angle is in the second quadrant, right? Should cosine be negative or positive in the second quadrant? Negative. So we're going to choose the negative option here because I'm in the second quadrant. So it's going to be negative square root of cosine's ratio, which we found to be -3 over 5 plus 1 divided by what?
2.
2. And this is why I wait until the end to do my radical, because it's never long enough. All right, what would you do next?
Change the 1 to 5.
Yep, so I can add them together. So I get negative, I'll do the radical later. I get -3 plus 5 all over the same denominator of 5.
And then all over 2.
And then all over 2.
What is that hypotenuse?
Huh?
I know the ceiling. I don't hear it. It stopped.
Sound like a cricket or
Right
something.
when I
Like.
said that. Jay, I think it's just good.
Nah, I heard it. It was like a little cricket or something.
No, he's trying to make it do
No, you're trying to make her feel crazy.
Yeah. She is crazy. Oh,
I didn't say that. -3 plus 5?
2.
2. Two divided by 5 all over 2. What's next? Keep change flip. So 2 over 5 times 1 over 2. 5 times 2 is 10.
2 over 10 is 1 over 5.
Yep. So 2 over 10. So just to be clear, I did 5 times 2 because that's what you get if you keep change flip. So in the bottom, 5 times 2 is 10. Everybody okay? Man, we're so close. Now, we normally get 4, and we can do the square root of 4 is 2, but I don't think we can do the square root of 10. But we can reduce this fraction inside the radical.
1 over 5.
We can reduce it to 1 over 5, since both numbers are inside the radical. If one of the numbers was outside, we couldn't reduce. But since both are in, we can. And what we get is negative root 1 over 5. What's the square root of 1?
Nothing. 1.
1. And I can't leave it like that, so I multiply the top and the bottom by the square root of 5. And after all of our good work, hard work, this is what we get. So I ran out of space. I didn't show the step, but here you multiply the top by root 5 and the bottom by root 5. Root 5 times root 5 is just 5. Every mathematician on earth.
Is this it?
That's it for cosine.
That's just the cosine.
More? Yeah, sine and tangent. Look how long tangent is.
I was gonna say, is tangent.
Well, we already know we can do sine over cosine for tangent, right?
Then we should do that.
You can do that 100%. I'll do the formula just so we see the formula, but if you find cosine and sine, just do sine over cosine. We'll get the same answer. All right. So really, we got like one more to go. Yep. Go for it. Oh, I thought you were wanting to go to the bathroom. I thought there was a bathroom dance. All right, let's do sine.
Party in the mountain right now, Jay. For real? Bye.
All right, so for sine, in the second quadrant, is sine positive or negative? In quadrant 2,
It's positive.
it's positive, so I'm going to choose the positive option.
Yeah, positive's right. Negative's wrong.
So I got 1 minus cosine of theta, which is negative 3 over 5. That was the ratio we started with right here. And then this is all divided by 2. When I subtract the negative, it becomes
Positive.
positive. And then I need to write 1 to be a number with the denominator of
2. 5.
5. So I get 5 over 5 plus 3 over 5. All divided by 2. 3 plus 5 is, 5 plus 3 is
8.
8. Can I go ahead and do 5 times 2 as well?
Yeah.
So 8 over 10. I just went on and did that in the same step. So I did 2 steps in 1. Everybody okay with that? Can I reduce this fraction in the radical?
2
2.
over, no, yeah.
They're both divisible by 2.
2,
8 divided by 2 is
4.
4. 10 divided by 2 is 5. What's the square root of 4? can't leave like this, I multiply the top and the bottom by root 5. This is what I get. All right.
Almost done.
Say choose back? Yep. Okay, so last one is tangent. And like we said, tangent is sine over cosine, right?
Yeah.
So I could. Now, I'm not going to do it this way because you might not do sine, cosine, and sine beforehand. But let's just see what we get. If you want, you can write it on your paper like this. But if you got a question and all you wanted to answer was tangent of theta over 2, you might not want to find both of these just to do tangent. You probably just want to use the formula. But if you do all three in this case, you could use the formula. So I know tangent is, let me say sine over cosine. And we already know these values. So sine was the one we just found, right?
Yes.
Divided by cosine, which was negative root 5 over 5. Yep, it's going to be a lot of cancellations. So I would keep this. I would multiply by 5 over negative root 5. And then the 5's cancel. What else cancels?
The root 5.
The root 5's cancel. And I'm left with negative 2. That's my answer. So if you want to stop there, and each time you will have to find cosine and sine individually, and then you can do this. You won't always have cosine and sine to find, so you might just use the formula. We'll use the formula, but this works. All right, so if you got space, or even on the back, you might make a little note and say, tangent equals sine over cosine. And we got negative 2 there. So I'll do the formula because sometimes it'll make more sense to just use the formula. It is, unless the only thing you answer is tangent. Then you have to do all this just to find tangent. All right, so let's do this last one. So now tangent, kind of like what we did the other day, you got 3 different formulas just based on where this formula comes from. You can use any one of these 3. If you're somebody who goes on YouTube and watches videos to try to help you understand this, somebody else might be doing any of the other formulas. If you go on Alex and say like, oh, help me solve this, you might see one of these other formulas being used. I think this is the one that I like using because it's only got like one thing in the denominator. So I think this is the one I like to use. Now, if you use this one, because cosine is the only thing involved, you'll have a decision to make on the sine. Okay, so tangent in the second quadrant should be what? Positive or negative? In Q2.
Positive, negative, negative.
Negative, because cosine's negative, sine. So it should be negative. But if you choose any of these 2, you don't have to worry about choosing the sine because you have a cosine and a sine. So the sine of the actual value of this will work itself out. If it's negative, it'll come out to be negative. So when we do it like this, we don't have to make a decision on what the sine should be. If you use this first one, because it's only got cosine in it, you have to choose. So we're going to do this last one. All right, so we're going to put 1 minus cosine over sine. So, man, it's going to be a tight squeeze. I apologize in advance if this gets ugly. But we will do 1 minus cosine which we said was -3 over 5.
I thought it was -5. Oh, you don't,
Right?
yeah.
So here's cosine. Divided by what?
Sine.
Sine. Sine's ratio was given to us, -4 over 5. This is my answer, just gotta simplify it.
Yeah.
Okay, so when I subtract the negative, there's no power sign here, so this will become positive, right? And I need to rewrite 1 to be a number with the denominator of what?
5.
5, so I can add them together. So I get 5 over 5 plus 3 over 5 divided by,
Why wouldn't you just put them together?
I could, for sure. You could do that. Just do 5 plus 3 over 5. In the top, I get 5 plus 3, which is 5 plus 3.
No, it could be like, so my brother's making it same.
5 plus 3, anybody?
8.
8 over 5. And in this step, I'm going to go ahead and keep change flip. So I'm going to keep this 8 over 5. I'm going to multiply by 5 over -4. Anything cancel or
5s.
5s cancel out? Just give me 8 over -4, right? What's that? Is that what we got when we did sine over cosine?
Yeah.
Wow, that's amazing.
That's crazy.